Hey guys, welcome back. In this video, we're going to talk about liquids and solids. All right, liquids and solids. And they're the three, and gases even. We won't even touch on gases. So the states of matter, right? You know you have solids. We have liquids. And we have gases. And so you guys know a solid, right? If we just did a solid, it's, right? I'll draw it as a square for whatever reason. There's our solid, right? A little irregular there, okay? Liquids, I need a container now, don't I? We need a container for the liquid, right? And the liquid is in that container. And so whatever the liquid is, it is in the shape of the container, right? Now, with these two, we call these condensed phases. So liquids and solids are condensed phases. Right? And what holds them together? Right? Intermolecular forces hold them together. Right? And those would be hydrogen bonding, dipole-dipole, and London dispersion. Those are the intermolecular forces that hold those particles of solids and liquids together. Whether it's a solid, whether it's ice, which would be hydrogen bonding, whether it's, xenon element, that's solid xenon or liquid xenon. And there's also gas. Now gas, all right, gases, that didn't work. Let's try that again. Usually it makes a circle. There it goes. All right, gas particles, we got all the gas particles that are in there. There's no shape. There's no definite volume. You get your gas particles. All right, so if we dive into these condensed phases of liquids and solids, right, a lot of these properties, all right, of the liquids, because solids will be a different chapter, all right, another video. Properties of liquids, they depend on the magnitude of the intermolecular forces. The magnitude. All right. And so these properties, what are some of these properties? Well, the first one we're going to talk about is surface tension. Surface tension. I'm sure you've heard of it before. This is why we don't go face first into the pool, right? If you have a pool, right? And surface tension is the amount of energy required to stretch or increase the surface of a liquid by a unit area. Typically 1 centimeter squared. All right. And so if you have strong intermolecular forces, that usually means high surface tension. All right. And so we're going to look at this for a second. So if we have water, so if I have a water droplet versus liquid water, right, on a surface, all the water particles in here, right, intermolecular forces, they're all, right, they're all pointed in, okay? My vectors are kind of in, and this guy can go everywhere. There's interactions with waters all around, right? Okay? So this is why water droplets, in zero gravity, water makes a sphere, right? Because if we look at the water here, right, there's some on the surface and some in the middle, right? In the middle, I have intermolecular forces going each way. However, on the surface, I can only do 180 degrees, right? I can only go 180. So on the surface, it's 180, not 108, sorry about that, 180 degrees. Or down here, it's 360 degrees. Right? And so that's why water is drawn into itself, because the ones on the surface are only being pulled, attracted into the surface. Okay? And since water likes itself a lot, right? Strong hydrogen bonding, that's why it spheres up. That's why it does this. Okay? And so things that do have low intermolecular forces spread out easily and, right, evaporate easily and all that. Now, with surface tension, depending on the intermolecular forces and what it is, right? When you talk about graduated cylinders, right? We have a graduated cylinder, water looks something like this. Okay. If you ever had a different one, different substance, let's say this substance would be mercury, which probably don't have at home. Mercury looks like, well, that's horrible. Let's try it again. Mercury looks like that. All right. And so when we measure these, right, you measure water there, and you measure mercury, well, there. There, right? Well, what's the difference? All right, there's two forces here, right, at play: adhesion and cohesion. Maybe you've heard those forces before. So adhesion, right? This is an attraction between unlike particles. Sometimes it's molecules, atoms, ions, whatever. Cohesion is an attraction between like particles. All right. So water likes itself, but water, if this is glass, let's assume that our graduated cylinder here is glass. Right? Glass is SiO2 plus some other stuff. Right? Well, the oxygen in the glass, water is going to like the glass. Water likes glass. And so it goes up. So in here, adhesion is greater than the cohesion. All right? The cohesion is the water liking itself. Well, water likes the other oxygens on the right, and so water will stick to the glass. Mercury has adhesion, right? But that adhesion is way less than the cohesion. Mercury likes itself more than it likes the glass, so that's why the meniscus is the opposite way. All right, and so that's all due to surface tension. Kind of neat. All right, another thing that's cool, when we have this situation here, right? When we have that situation, another thing is cool is capillary action, right? So this happens when, of course, adhesion is greater than cohesion, right? And this is also important, the tube or cylinder is narrow. Right? And the more narrow, the more we can go, right? Liquid can flow up the tube. I mean, this is an amazing property. Think about trees and how they get water up to the top. There's not like trees have pumps in the ground, right? They use these properties to get water way up high. All right. Another fun thing, another property of liquids now is viscosity. All right. And viscosity, right, is a fluid's resistance to flow. Now, it's usually measured in newtons times seconds per meter squared. All right. All right. Now, it typically decreases with increasing temperature. So that means as the temperature goes up, the liquid flows more. All right? And the key point here is that strong intermolecular forces equals larger viscosities. Right? There used to be a commercial years ago about a certain motor oil that would stick to the machine parts, which is what we want, right? And engines and cars get hot, right? Those internal combustion engines. And you want your oil to stay on the parts because you do not want metal rubbing on metal. You want the oil between them, right? That's just, it works better that way. Oil, right? That lubrication makes it work. All right? And so you want the oil to kind of stick to the metal in a way, all right? Or not flow off of it. Right, syrup's a great example of this. If you guys do syrup stuff, whether it's genuine maple syrup or whatever you get at the grocery store or whatnot, right? If you make it warm, it flows way better than if it's cold, all right? So you guys probably experienced that. So those are some of the properties of liquids, with the solid, liquid, and gas. Those are some properties of liquids. The next property we're going to talk about in the next video is vapor pressure, and we're going to spend some time on that one. So hopefully that's good. If you have any questions, let me know. Otherwise, we'll see you next time, guys. Take care.